Good morning, or actually I'm sure for some of you, good afternoon. All right, so we're still in our exponents portion of the packet, and I am currently on page 7. So what I'd like you to do is I'd like you to read numbers, all the examples on this page, 22 through 24. Try them on your own, see what you can do. Some of them are a little tricky, and then, hit play and see how well you did. Okay, and one thing I'm noticing here, the number 22 doesn't really make sense. If you can cross off that word expression and change it to an exponent. So you're rewriting this as a single term with a rational exponent. Okay, well, if we want to write this as a single term with a rational exponent, the first thing I want to do is I want to get these out of radical form, and I want to just put them so they have, exponential form, so they have exponents. All right, so if this says the cubed root of x, really to the first power, we can rewrite that as x to the 1/3 power, because remember, using power over root, this is equivalent to the cubed root of x to the first power, which is exactly what our original expression said. Okay, and now if we look at the second term here, this says the square root of x to the first power. So that means we could rewrite this as x to the 1/2 power, right? Using power over root, we put the root here and the power here. So this is the square root of x to the first power. That's, what our original expression said. All right, now we want to rewrite this as a single term. So here, whenever we multiply two terms with the same base, we just add the exponents. All right, so if we want to add, I'm going to do it off to the side here. If we want to add 1/3 plus 1/2, we have to find a common denominator. So our common denominator is going to be 6, right? If we listed out the multiples of 3, 6, 9, and so on, and the multiples of 2, 4, 6, 6 is the lowest number they have in common. So I can make the first denominator into a 6 by multiplying it by 2. And if I do that to the denominator, I also have to do that to the numerator. All right, I can make the second denominator into a 6 by multiplying it by 3. And if I do that to the denominator, I have to do that to the numerator. All right, so now that leaves us with 2/6, and then plus 3/6. All right, so 2/6 plus 3/6 will be 5/6. Okay, so I'm going to rewrite this, right? If we multiply two terms with the same base, we keep the base, so I'm going to keep the x, and we add the exponents. And actually, we are done, because they wanted us to rewrite this as a single term, which it is, with a rational, which just means fractional, exponent. So that one's done. All right, let's take a look at number 23. Let's see how you did with that one. Okay, so this one asks us to use the property of rational exponents to determine the value of y for the equation. All right, so they want us to somehow, simplify or combine this left-hand side of the equation so that we have it in the form x to some power. And then whatever that power would be the value of y. Okay, so let me show you what I mean. All right, now first thing, on the top here, we have our term is written in radical form, whereas on the bottom, it's written with exponents. Whenever you want to try to get two terms into one, you want to rewrite them both so that they're in exponent form, not radical form. So the first thing I'm going to do is I'm going to take this numerator out of radical form. So here, since we have the cube root of x to the 8th power, if we use power over root, we can rewrite that as x to the 8/3 power. Okay, so I'm going to write this as x to the 8/3 power. Okay, now in the denominator, remember, if you have a power being raised to another power, you just multiply the exponents. So 4 times 1/3, I'm going to do it off to the side. 4/1 times 1/3 would just be 4/3. So in the denominator, we have x to the 4/3 power. And then I'm going to bring down the right-hand side of the equation. Now, I just want to say, this right here says x is greater than 1. You can basically ignore that. They have to put that there to be technically correct. They're saying that this equation holds true for all values of x that are greater than 1, okay? So if x is less than 1, so if x was, 1/2, this wouldn't hold true. Okay, so now, here we still have, on the left-hand side of the equation, we have two terms that contain x's. Now, if you remember your rule, if you're dividing two terms with the same base, don't we just take these exponents and subtract them? Okay, so let's think about this. I'm not even going to do this off to the side. 8/3 minus 4/3 would be 4/3 because 8 minus 4 is 4, and you keep the common denominator. Okay, so 8/3 minus 4/3 is 4/3. So it leaves me with x to the 4/3 equals, and then I'll bring down the right-hand side of the equation. Now, what they wanted us to do here is they wanted us to determine the value of y. Well, let's think about it. Since y is the exponent on the x here, and since 4/3 is the exponent on the x here, doesn't y have to be equal to 4/3? Okay, so that is our answer. Y equals 4/3. All right, so let's now take a look at number 24. It says, given equal terms, determine and state y in terms of x. Okay, so first thing, they're saying that these two terms here are equal. So what I'm going to do is I'm going to set them equal to each other. So the cube root of x to the 5th equals y to the 5/6 power. Now when it says to determine and state y, okay, that's another way of saying solve for y. And when they say in terms of x, that's another way of saying there will be an x in your answer. Okay, so you're not going to wind up with some numerical answer like we did up here in number 23, we wound up with 4/3. We're going to wind up with an x in our answer. Okay, so first thing I'm always going to do, you always want to get everything out of radical form, okay? Because that's how you can combine things and move things. So using power over root, I'm going to rewrite this side of the equation as x to the 5/3 power, right? Because power over root. Okay, this is the cube root of x to the 5th power. So here's our power, here's our root. And then I'm just going to bring down the right-hand side of the equation. Now it wants us to solve for y. So if we want to solve for y, we need this to say y to the 1st power, not y to the 5/6 power. So we need to get this y, we need to get this 5/6 off of here. Now let's think about it. We know if we were to raise a power to another power, right? We multiply those powers. So if I want this to say y to the 1st power, I can take this side of the equation and raise it to the reciprocal power of this. Reciprocal means to take it and flip it upside down. Because, think about it. If I multiply 5/6 by its reciprocal, wouldn't that leave me with 30 over 30, which simplifies to 1, right? So that'll leave me with y to the 1st power, which is what we want, which is just y, right? Because those cancel. Now let's think about this, though. If you raised the right-hand side of the equation to the 6/5 power, don't we also have to raise the left-hand side of the equation to the 6/5 power, right? And please do not put your exponent on the left. You know, you might be like, oh, it fits better over here, but an exponent always goes on the top right, so make sure you do that. Okay, so you could do this you could multiply these one of two ways. If you want to multiply across, 5 times 6 is 30, and 3 times 5 is 15. And doesn't 30 over 15 simplify to 2, right? 30 divided by 15 is 2. So it leaves you with x squared, x to the 2nd power. Or if you wanted, what you could have done is you could have, remember, you can cancel anything on top with anything on the bottom. It doesn't matter what fraction it's in when you're multiplying. So I could have canceled this 5 with this 5. And then isn't 6 divided by 3? 2? Okay, so anyway, we solve for y, here it is, and in terms of x, it would be an x in our answer. So y is equal to x squared. There it is. Okay, so now I'm on page 8. If you turn to page 8, I'd like you to try out the first 2 questions on this page, so number 25 and 26. And then again, you can check with my work and see how you did. All right, so number 25 wants to know which expressions are equivalent to 1 divided by the 6th root of x. So 1 divided by the 6th root of x. All right, so I'm going to go through each of these answer choices one by one and see which works. Okay, so choice 1, I just wrote down here, and I'm just going to take this out of radical form. So using power over root, this is the 6th root of x to the 1st power. So I can rewrite that as x to the 1/6 power. right? Because again, it's power over root. So the 6th root of x to the first power is what this originally said. Okay, so same thing. I'm going to rewrite this as x to the power is 1 and root is 3. So x to the 1/3 power. Okay, so now we know if we're dividing two terms with the same base, we're going to subtract these exponents. So I'm going to just do that down here off to the side. So 1/6 minus 1/3. So I want to find a common denominator, and that common denominator is going to be 6. Right? This already has a 6, and if I multiply this 3 by 2, it'll become a 6. But if I multiply the denominator by 2, I have to do the same thing to the numerator. Okay, so this leaves me with 1/6 minus 2/6. And here, since 1 minus 2 is -1, we get -1/6, right? Because you keep the denominator. You subtract the numerators and you keep the denominator. Okay, so we can come back up here and rewrite this as x to the -1/6. Remember, we don't like negative exponents, right? So we want to make that positive. So I'm going to make this into a fraction by putting it over 1. And then to make an exponent positive, you take the term that contains the negative exponent and you move it to the other side of the fraction bar. So if I take this and move it down to the denominator, that exponent becomes positive. So I get x to the positive 1/6. And then technically there was a 1 in front of this x, right? So I'm going to take that 1 and slide it over so that we have a placeholder in our numerator. Now, we want to know, is this equivalent to 1 over the 6th root of x? Well, it is, because think about it, power over root. Wouldn't this be the 6th root of x to the first power? So in the denominator, we're going to have the 6th root of x to the first power. And you don't have to put the 1 there as your power, right? But we also have to take this 1 that was in the numerator and bring it down. So look at that. These match. Okay, so choice 1 works. Now, if you notice, you don't even have to try out choice 2, because look at this, choice 2, wasn't that an in-between step right here with number 1? So look, we've already followed that through, so we know that one works too. All right, and let's look at choice 3. Well, look at this, choice 3, x to the -1/6. Isn't that what this says right here, x to the -1/6? So that was also an in-between step, so you don't even have to determine that one. So that one works as well, so they all work. So choice 4 is the answer. Okay, the other one I wanted you to try out on this page was number 26. Now, there are so many different ways to go about doing this one. It's up to you what you want to do first. You could either take this exponent and distribute it on to the numerator and the denominator, or you could say, look, I have a negative exponent. I can make it positive by flipping this fraction upside down. I think what I'm going to do is I'm going to start inside the parentheses. Look at this. If we have division, right? If we're dividing two terms with the same base, right? They both have a base of m. Don't we just subtract those exponents? So I'm going to start off by doing that. Okay, so if I want to subtract, right, 2 over 1 minus 1/3, okay, I'm going to subtract my exponents. I have to find a common denominator. Now this one has a 3. I can easily make that into a 3 by multiplying the 1 by 3. But if I multiply my denominator by 3, I have to do that by the numerator as well. So that's going to leave me with 6 over 3 minus 1 over 3. And then since 6 minus 1 is 5, that leaves me with 5/3. Okay, so I'm going to take this and rewrite this as m to the 5/3. And then I have to take that -1/2 that's on the outside and bring it down. Okay, so that's how I decided to start. I thought this way might be a little faster. Okay, now, when we have a power raised to another power, don't we just multiply those exponents? Okay, so this is going to leave me with m to the, all right, well, first of all, a positive times a negative is a negative, so we're going to have a negative fraction. And then since 5 times 1 is 5, and 3 times 2 is 6, it'll be -5/6. Okay, and we don't like to have negative exponents, right? So let's make this into a fraction. Let's put the whole thing over 1. And we know that if we take this term and move it from the numerator down to the denominator, the exponent changes its sign, right? It goes from a negative exponent to a positive exponent. So now in the denominator, we have m to the positive 5/6. And we have to put a 1 in the numerator as a placeholder. Okay, now if I look at the answer choices, we have radicals in these answer choices, so let's rewrite this in radical form. If we do power over root, the denominator will be the 6th root of m to the 5th power. So again, the denominator will be the 6th root of m to the 5th power. Oop, that's supposed to be a 5. All right, and then on top, we put a 1. Okay, so if we look, that matches up with choice 2. Okay, and if you can turn to the next page, the only example we're going to try on this page is number 28. So I'd like you to try it on your own. This was a multiple choice on the regions. I think you guys can all handle this and then see how you did. Okay, so in number 28, they're telling us that n is equal to the square root of a to the 5th power. And they also tell us that m is equal to a. And they want us to basically determine what this expression is equivalent to, n over m. So let's think about it. I'm going to write n over m. Now, didn't they just tell us that n is equal to the square root of a to the 5th? So let's write that, the square root of a to the 5th power. And then didn't they also tell us that m is equal to a? So I'm going to replace this m with an a. All right, and then it looks like we just have to, since we have an a in the numerator and an a in the denominator, we want to try to get these into one single term. Now, in order to do that, I want to get this out of radical form. It always makes your life easier if you take anything that contains a radical and get it out of the radical form. Okay, so since this is the square, even though we don't see a little 2 there, this is the square root. If you want to put a 2 there, go for it. You can put a little 2 there, right? So this is the square root of a to the 5th power. So if I want to rewrite this using power over root, it would be a to the 5/2 power. And then I'm just going to bring over this a on the bottom. And I'm actually, if you think about it, doesn't that a technically have a little exponent of a 1? I'm going to put that there so it helps me with my next step. Now in the next step, we're dividing 2 terms with the same base. So we know when we do that, we have to subtract our exponents. So let me do that off to the side. So 5/2 minus 1. So minus 1 over 1. So my common denominator is going to be a 2, because I can get this to say a 2, because 1 times 2 is 2. And if I multiply the denominator by 2, I have to do that to the numerator. All right, so that leaves us with 5/2 minus 2/2. So when we subtract the tops, we get 3, and we keep the bottom as a 2. So basically, 5/2 minus 1 is 3/2. So I'm going to rewrite this as a to the 3/2. Okay, if we look at our first 2 answer choices, right, they're rewritten without radicals, kind of like this is here. But look, neither one of those match up with this. Neither one says a to the 3/2 power. Now, these are rewritten in radical form. So if we want to rewrite this in radical form, power over root, it would be the square root of a to the 3rd power. So the square root, remember, you don't have to put a 2 there if it's a square root. If you want to, go for it, but you don't have to. So the square root of a to the 3rd power. And it looks like that matches up with choice 4.